Hey folks, so in this video what I thought I'd do is show you how to run through this particular problem here, which is an exercise in your textbook, but just going through the process of unit conversion and how to approach problems like this. Alright, so what we've got here is this problem where we've got a rhinovirus that is responsible for the common cold that has a diameter of 30 nanometers. All right, so that's a key bit of information. And what we're trying to do is figure out how many of these particles we can have side by side on a line that's 1 inch long. So how are we going to approach this? Well, usually the first thing I do when I start a problem is just to write down the information that I'm given. So I'm just going to write this down so that I've got, the diameter of the virus is equal to 30 nanometers. Okay, and then I've got a line that is, we'll just call that L, 1 inches long. All right, so just as an aside here, I know that 30 nanometers is 3 times 10 to the minus 9 meters. And I know it's a lot smaller than 1 inch. And we're going to get into the conversion and all of that. So we're going to get quite a few of these viruses that we're going to be able to line up along here. But how do we do that? So that's the question. What is our approach to this problem? All right. The first thing to note, of course, is that we've got a disconnect between the units. We have one set of units in nanometers and the other set of units in inches. So clearly we're going to have to do a unit conversion. Either we convert nanometers to inches or inches to nanometers. Either way, either approach will work in this particular case. What I'm going to do is I'm going to convert the nanometers into inches. Right? So I'm going to get, in other words, what I'm going to do is figure out, all right, so I have a diameter of 30 nanometers for the rhinovirus. How many inches is that? All right, so we'll go ahead and we're going to plug that in. We're going to need a conversion factor. And so here I'm going to start by writing the 30 nanometers. Now, what do I know about inches? All right, how am I going to do this conversion? I need to know the relationship between inches and nanometers in order to get this to work. So we're going to have to look that up. Depending on your source, you might get, a conversion factor in terms of centimeters or a conversion factor in terms of meters. Most commonly, you're going to see it in centimeters because we have this factor that 1 inch is exactly 2.54 centimeters. And again, we can look that up. We can look that up in a table. You can look that up on the internet. You can Google it. You can ask that question, what is our conversion factor? All right. All right, so that's centimeters. And so what we're going to need to do is then let's first convert nanometers to centimeters, all right, so that we can then convert centimeters to inches. All right. So how do we go about doing that? And there are several ways you can do it. It's going to depend on what you're comfortable with. I'm going to do it in steps that I would expect if I'm looking things up in a table, how I might go about doing it. So I know that 1 nanometer is 10 to the minus 9 meters. Nano means 10 to the minus 9. Okay? So let's first convert it to meters. And so how do we go about doing that? So I'm going to use that conversion factor. Now the thing to remember is how I orient the conversion factor, because sometimes there's confusion about what do I want in the numerator, what I want in the nanometer. We want to work it out, so I'm going to get an answer in meters, all right? And I want to cancel out nanometers. This is our approach to this. And so what I'm going to do is I'm going to write our conversion factor with the nanometer in the denominator. 1 nanometer in the denominator. All right. And 10 to the minus 9 meters in the numerator. Now, why did I do it that way? Well, I did it that way with nanometers in the denominator because the nanometers will now cancel out. All right? And so that means when I multiply this through, I'm going to get 30 times 10 to the minus 9 meters. And by the way, I should have written 30 up here at the top at the beginning as opposed to 3. So 30 times 10 to the minus 9 nanometers. So just multiply that through and we're fine. All right. So I've got my diameter now in terms of meters. But if I'm going to use this conversion factor here, what I'm going to have to do is change that to centimeters. All right? So this is where I need to know the definition of a centimeter. And again, I can look at it in my table, although these, what you should know, all right, there are certain things I do expect you to know. You should know that a nanometer is 10 to the minus 9 meters. This is information I will not be giving you on an exam, for example. You should know that a centimeter is 10 to the minus 2 meters. I am not going to expect you to memorize that 1 inch is 2.54 centimeters, but I do expect you to know the prefixes like we talked about in class. So in any event, this is what I've got here. I've got 30 times 10 to the minus 9 meters when I multiply it through, all right? Or if we wanted to put it in terms of our scientific notation, 3.0 times 10 to the minus 8 meters, both of those would work. So I've got that. So let's move down to our next step here, where I'm going to convert my meters to centimeters. All right. And so 3.0 times 10 to the minus 8 meters. All right. And again, using our conversion factor of 10 to the minus 2, 1 centimeter is 10 to the minus 2 meters. So again, I'm arranging it. I'm getting rid of meters and replacing that with centimeters. So that means I'm going to put meters in the denominator and centimeters in the numerator. 1 centimeter is 10 to the minus 2 meters. All right? And so then I'm going to get an answer in centimeters. Now, if you're doing this in your calculator, and certainly if you have questions about how to do these kinds of things in your calculator, make sure you ask. I know there's some ways that you can get confused about how to enter exponents in your calculator, and I can't necessarily demonstrate that in this particular video. But if you're working on this and you're not clear about how to enter things in your calculator, I do want you to ask me so that I can help you with that. So in any event, what you should get when you do this is 3.0 times 10 to the minus 6 centimeters. All right, that's what we're going to end up with. So now I know that my diameter is 3.0 times 10 to the minus 6 centimeters. All right, so now convert to inches. And I do recommend that when you're first learning how to do this, that you do it step by step, as opposed to doing it all in one step, because it is possible to do these problems once you become comfortable with it. You could do this all in one long step, just keeping in mind cancel units, cancel units, cancel units to get that to work out. So I'm going to go ahead now at this point, I'm going to go ahead and convert it to inches. So I'm going to start with my 3.0 times 10 to the minus 6 centimeters. And now what I want to do is convert to inches. So I'm going to use my conversion factor here, that 1 inch is 2.54 centimeters. And keeping in mind, I want to cancel out the centimeters, so that part has to be in the denominator. And the inches in the numerator. All right, so again, centimeters will then cancel out, and I'm going to get an answer in terms of inches. Okay, so when we do that, we're going to get a number that's about 1.18 times 10 to the minus 6 inches. All right, so that's the diameter of the rhinovirus in inches. And again, this could have all been done in one step by just carrying it through. But at least at this point, I wanted to do it multiple steps just to kind of run through what we're going to do. All right, so that's one. So now the question is, how many particles in that 1 inch? And so one of the things I like to do in a circumstance like this, since it's one particle, or excuse me, one virus, I'm going to say this is inches per virus. All right, that's one virus. So that's going to help me kind of keep units straight when I'm figuring this out. So if I want to figure out how many viruses I'm going to get, I'm going to do another unit conversion, which is going to give me viruses. So I know that I've got 1 inch. Okay, so I'm going to start with 1 inch. Okay, and now I want to change that to the number of viruses. So what I'm going to do here is recognizing that inches need to cancel out. So if I do 1.18 times 10 to the minus 6 inches, all right, because that's the number I got here at the end of that, inches, and that's for one virus. All right, so inches are going to cancel out, and you'll notice that the units I'm having left are going to be in terms of the virus. So what we're going to do is we're going to take that and plug that into our calculator in order to find out exactly how many viruses I have. Okay, so we do the calculation depending on the display in your calculator, and you might get something that is $846,667. Again, just rounding things off. There's nothing after the decimal point here because we have too many sig figs already. So this is where we would ask questions about significant figures in a problem like this. How many sig figs should we have? So we'll note that we've got 30 nanometers. Now, the way that's written, all right, with the 30 nanometers, since there's no decimal point after the 0, the 30 nanometers has one significant figure. On the other hand, if it was written 30 with a decimal point, that would have two significant figures. All right, so 30 has one sig fig. The length in inches is 1.0. That's got two significant figures because we count the 0 after the decimal point. So that's got two significant figures. And so we've got one sig fig in the calculation is the minimum number. So that means our answer really should only have one significant figure. And so given that, the way we would write that in scientific notation is with one sig fig is 8, all right, and that's our one sig fig times 10 to the 5th viruses. And usually with your displays on your calculator, you should be able to set your display so it shows the scientific notation rather than showing all of the digits written out. And that's generally, in chemistry, that's generally how we're going to want to write it. We're going to want to write it in scientific notation. So what we're doing is, of course, because these other digits are not significant, we have to round off. And we're going to round off because 846,000 is less than half, way between 8 and 9. We're going to round down to 8 with our 1 sig fig. So that's an example of how we can move through a unit calculation here, canceling the units that we want to get rid of and ending up with the units that we want. In this case, the units would be viruses that we want in that line. So hopefully this is clear. Just make sure if you got any questions, you let me know.